We like let's start off. All right. So till now we have understood what a programming language is, how you can basically convert that programming language into machine code using a translator. And in our today's class, we're going to be exploring that specific software which basically compiles all these other features which a programmer requires. So it's not like a programmer is going to be doing the coding at one place, because we saw that okay, we need to code somewhere, right? So we need some sort of an editor, some place where we can write code. We need this thing. Then we saw that okay, we need a translator which is basically going to compile the code into machine or into object code. And just like that, there are multiple other features which a programmer might be requiring at specific places. But if a programmer is basically dealing with each of these features separately, you can understand that it's going to basically be very, very complex for him or her to make an object or make an application out of it. So, for that reason, what software programmers did was that they created a software known as integrated development environment, which is basically given the short form of IDE. And what an IDE basically does is that it basically compiles all these sort of different softwares, like a compiler, interpreter, or maybe like a code editor, and gives a lot of various features to a user or to a programmer, allowing them to basically deal with all these programming related things within one single software. So it basically makes it pretty much very easy for a programmer. And now at this point, for you all, the important point here to note is that we're going to define what an IDE is, and then followed by that we're going to look on to some common features of IDE. Walaikum Assalam, Ramin, how are you doing? So let's move on to firstly defining what an IDE is. So I gave you guys the general overview of what an IDE is, but to formally introduce it, an IDE is a software that provides the programmers with tools to write, edit, test, and debug programs in one place. Say, so an IDE is a software that provides programmers the capacity or maybe the tools to edit, write, test, and debug programs. So it's basically a set of programs where what you can do is that you can write your code within it, you can basically test it, you can solve and look for problems within it, and if you find those problems, you can basically sort of find solutions for it too. Now, if anybody of you have ever looked onto some sort of programming languages, you're going to note that if anybody of you wants to explore Python, it's generally recommended that if you want to write the Python's code, you need to use a software known as PyCharm. Now, what's this PyCharm? This PyCharm is basically an IDE because it provides you all the tools which allows you to write the code in the right way. Just like that, for the other programming languages, like including Python or like for C++, there is something known as Visual Studio, which I was even using last night, if you guys remember. So that's one other sort of an example for an IDE, which could be basically used by a programmer for multiple reasons. So right now I'm going to be sharing this IDE screen with you all. It has a built-in compiler exactly. वो मैं आपको सब बता दूं. Just give me a minute. So right now you guys can see this on your screens, right? We wrote this code last night, and the purpose of showing this to you is to tell you basically about a few important things. So right now, this whole thing which you guys see in front of you, this is an IDE. Now this software allows me to write code. You can see I wrote this statement last night, right? I can write code whatever I want. I want to print something else, I can do like okay, output 2 plus 3. Okay, I can do this. I can write any sort of statement. At the same time, I can also run it. So like by pressing this button, you see I can basically compile the program. And up here, I have the statement printed, hello, hey, alongside the number 5, which comes from this statement. And apart from that, if let's say there is an error, like I forgot this semicolon, if I run it again, you're going to see that it also allows me to debug it at the same time because it's giving me the error. Whereas not only this, it has multiple other features, such as like you're going to see that there are different colors for each of these statements. This is a bit yellow, this is a bit blue. Then you see that it basically allows me to have sometimes auto completion, as if like if I'm missing out on this thing, you're going to see that up here I get this red line beneath it. and up here you can see a red color is being formed, which is basically an indication to tell me that something is wrong up here. And so it also allows me to understand where I made the mistakes, right? Line number 7, so it shows that line number 7 has some sort of an error. So this software has a lot of features which allow a programmer to basically write code in a much better way, and we're now going to be exploring what those features are alongside a small description of what they are. Now in your exams they won't be giving you like a IDE like this, but rather they're going to say that what's this feature, what's that feature. So we're going to be formally looking into all of them. Say, so back to the note taking app. Now we have seen what an IDE is, right? It's that software which provides you with this whole um, platform to basically write, edit, test, and debug programs in one place. The word one place, I didn't wrote right there, but in one place. That's important. In one place. It's not like you need to look onto multiple applications. But now the point which is important for us right now would be the fact what are the common features of IDE. So we're going to look into common features of IDE. So the first and the foremost feature of an IDE is basically the code editor, the section where you can basically write the code. A code editor is that specific place which I just showed to you all. It's like that special text editor where you can write source code. What is source code? It is the code which is written in a high level programming language, right? So it's a special text editor for writing source code. A special text editor, a special text editor, text editor for writing source code, for writing the source code. Then afterwards, your code editor basically is, why am I calling it special? It's not the normal text editor like Microsoft Word or some note taking app where you can basically write stuff. It has some special features assigned to it, and such as like it highlights keywords, it highlights variables, functions, and syntax, and sort of gives it a different color, like you just saw right now, right? One of the things had a color of blue, the other had orange, the other had white. Now why were they having different colors? We're going to come to that inshallah when we discuss paper number 2, because all of these different things have a different characteristic assigned to it. But the benefit we get out of this is that basically when we have different sort of things existing, it allows us, this special code editor basically allows us to look onto it in a different way by just highlighting it differently. So it highlights keywords, highlights, highlights keywords. What are keywords? Something like print, something like input. Okay, then variables. What are variables? Those things in which I'm storing data. Then maybe some text, if I have some functions or whatsoever, any command which I'm giving to the IDE, it is going to highlight it in a different way. And if there is some sort of a problem, then it can also highlight that by indicating that your syntax is wrong. And what syntax? Syntax is basically your rules or the grammatical rules for a programming language. So people usually are not aware of what syntax stands for, but syntax basically means programming language grammar rules. Say grammar rules. So if I have to just share one picture with you guys, just give me a minute. Let me take the screenshot. This thing in front of us, which I was just showing to you all, is my code editor. And it basically allows me to write code, and alongside that it also is highlighting each of these things separately. This is blue, this is light blue, this is like orange. Now everything that's orange is basically text, and then everything that's basically having this yellowish tint, that's basically a function. Now what functions are, what are these texts, what are these other statements, that is something we're going to look into in paper number 2. But for now, just you should understand that IDE basically highlights each of these different things with different colors for us programmers to understand that if later on somewhere I see something like, okay, int xyz, and it's being within the same yellowish color, it's going to tell me that okay, this is a function. So even if I'm not aware that xyz is a function, by just looking onto its color, I can sort of figure out that yeah, because yellow is the color for functions, this means that this thing also is a function. And this basically allows programmer to understand what this specific thing is, because in these large sort of companies, not a single person is writing code, right? We have a whole team like 15, 20 people. No, not only error, it highlights everything. So like if I say that I'm writing text up here in this code, this text has been denoted by a color which is sort of similar to orange. Now, anywhere where I'm going to be writing text, it's going to be in this orange color because it's within these quotation marks. If there is some place where I'm sort of highlighting or writing some function, that function will always be having a yellowish tinted color like this. Just like that, if I give it a command to, let's say, print something, or like these statements where I'm printing something out of it, this command is in blue color. So the purpose of this is here to understand and to tell the programmer that we have sort of a newer action being performed, and every action is basically given a different color so that the programmer can understand what action is being performed at this point. See out is in blue color. It's basically telling us that, okay, this is an action which is printing something. Whereas up here, this function which I'm declaring, it has a yellowish color. Now it's telling the programmer that, okay, this is a function. So it's sort of like we have different types of actions within a programming language which can do different sort of steps. So I can basically create a function, I can make a variable, I can do multiple things. Now what a function, what a variable is, that's a discussion we're going to do in paper number 2. But the point here to explain to you all is that whenever we are writing code in an IDE, it highlights and it sort of gives a new color to every different thing, so that we can understand that if there is something of different sort of nature, how it sort of allows us to understand that this thing is of this type. So like for instance, as an example, let's say that in this class, let's assume we have one student from grade 9. Okay, then we have one student from grade 10, and then we have one student from grade 11. Okay, now I, let's say, assign a duty to the grade 9 students, and I tell them that, okay, your task is to, let's say, do math RA, or like do math calculations. We are working on a project and this thingy is doing math calculations. Then grade 10 students are assigned the duty to write the report. Okay, write report. Whereas grade 11 students are basically sort of given the task of raising funds. Okay, so we sort of gave different tasks to the three classes we have right now. Okay, just like that, in your computers or when you're programming, these things which I just mentioned, functions, variables, these input output commands, these texts, they sort of have different usages. Everything does us, like each of them have a different role, a different purpose, and all of them performs a task which allows us eventually to have a program being created. Now, what the programming IDE does is that it gives a color to each of the tasks. So, like if we have a grade 9 student, all the grade 9 students would be having the similar sort of color, such as this yellowish orange. Then, if we have a grade 10 student, the grade 10 will be having red sort of colors, right? If we have a grade 11 student, all of the grade 11 students will be having this blue color. And similar to that, if I now have a student which I'm not aware of, but he's wearing a blue sort of shirt, a blue shirt, I can clearly look onto his shirt and I can understand that, okay, if he's wearing blue shirt, this means he's from grade 11, because all grade 11 students are raising funds. And so this person will also be raising funds, right? So the similar model gets applied in an IDE. So like each of these different thingies are assigned a different color. And then what happens is that we look onto these colors and they basically tell us that this specific command is of this nature. So maybe I say that this main thingy is a function. So anywhere where we have this yellowish color, which you can see up here, it's going to tell me that, okay, this is a function being applied in here. So it sort of allows the programmer to see that if we have a code somewhat, like I say Moise wrote a code and then I open that code in my IDE, the benefit I get is that if Moise, rather than making it main, he gives it some other name. Let's say he gives it as the name the XYZ, but it's still a function, right? Because it's going to have the same color, the yellowish color. So now when I look onto it and I see that it has the same yellow color, it allows me to understand that, okay, no matter what the name is, it has been declared as a function. And so it allows a programmer to basically understand what's happening within the code in the right way. And that's the first purpose of having, or perhaps the first feature of your IDE. And it allows you to. So yeah, so it's basically the first feature. Thank you. So it's basically the first feature we need to know when talking about IDEs, the code editor. Now, coming to the second point, but before that, is this clear? Do you guys understand the logic of having this special sort of text editor which highlights everything? Everyone in the chat box, quick. Perfecto. Perfect. बाकी बताएं, everyone quickly. Great, great, great. Smile clear, perceive clear, moise clear. Chalo, perfect. Okay, good thing. All right, so that's great to know. Okay, so now we have seen one of the multiple features our IDE has, but our IDE sort of, what do we call it, is not only limited to writing code. We saw that our IDE also has a few other features, and that is that it also has a built-in translator or a compiler within it. So the second feature of an IDE is that it has a translator present in it. Now, this translator depends upon the IDE. Sometimes a translator of like compiler nature might be installed, or sometime it might have an interpreter, but generally we were going to be calling it that an IDE will always be having a translator. Now if I'm dealing with C++ programs, any compiler or any IDE which basically translates C++ language will be automatically having a compiler. But if I'm sort of writing code in Python, because the nature of Python language is sort of where, oh yaar, ek to ye screen sharing kyun band ho jati hai, my bad. But if let's say we had Python, Python has basically this characteristic that where you want to translate it, you need to have an interpreter present for it. And so, like if you make use of a Python-based IDE such as PyCharm, it's going to have an interpreter in it. But if I make use of Visual Studio, like the one which I was showing to you all, that is going to have a compiler. But the main point here to note is that whenever we have an IDE, it is always going to have some sort of translator. And what's the translator going to do? It's going to convert your source code into machine code so that the computer can run it. So we're going to write it as in converts your source code into machine code, into machine code, so that your computer can run it, so that your computer can run it. Apart from that, while talking about translators, it's also important to understand that these translators also provide you with the chance of highlighting if there are any errors within your code. So we say that a translator within your IDE also allows you to test and run programs within the IDE. Test and run programs within the IDE, within the IDE. So, like for instance, the one which I just showed to you all, you saw that. Wait a second, let me even take the screenshot for you. So, up here in the IDE, you had a look onto how when I was trying to print it for you all, the code was executed within the IDE. It's not like I got the output in some file. Yeah, maybe a file might have been generated, but at the same time, I got the result up here within the IDE. So that is one other benefit. And similarly, if there was some sort of an error, it also gave me the error beneath it, which isn't covered within the screenshot, but still you can see that I'm getting my errors. And if there is something being executed in the right way and it's running properly, then that part is also covered within the IDE, which is the second feature, because I don't have to wait for a separate report to be generated, or maybe for a separate file to be created, which then I'm going to run to look whether it's running in the right way or not. This IDE provides me with all these features. And for a programmer, it's really important that we have all this all together, because it's going to help us save a lot of time. Apart from that, your IDE's third main feature is that it has a runtime environment and debugger. The same point which we were just discussing. Runtime environment, plus debugger. So what's a runtime environment? Runtime environment is basically this specific section where you can run the codes within your IDE, this place, this terminal which we have beneath, right? So I'm getting everything that's being working correctly up here. This is being run in the right way because my IDE has a runtime environment installed in it. And just like that, if I miss upon this semicolon which we have up here, you saw that it's going to give me an error. And that error basically is provided to me by the debugger which I have within my IDE. So this is the third feature which is really important, because in exam they can ask you to define what a runtime environment is. So you should be aware that it basically allows you to firstly run your program inside the IDE, run your program within the IDE, and followed by that IDE. It gives you the chance to basically test them. Now, okay, we generally saw that your IDE can help you test programs, but how can you test it? Like it's not like it's just going to give you an error. There are multiple approaches used by a programmer to find errors within the code, and we call those approaches basically debugger tools. So this debugger which we are just discussing, it provides us with some tools. Provides debugger tool. And what are these debuggers tool? These are basically those specific sort of approaches or those specific tools used by programmers to sort of find errors within your code. So for instance, the first one is known as single stepping. So what is single stepping? Single stepping basically is a concept used by programmers where they want to find an error in their code, what they're going to do is they're going to read one statement, they're going to test that, and then they're going to see whether it's working or not. If it's working, go to the next line. Then they're going to test the second line. Then they're going to test the third line, the fourth line, and so on. So the first way of finding errors within your code is known as single stepping, which basically means run program line by line. Run program line by line. So like if I'm coding and there is some sort of an error in my code, what I'm going to do is I'm going to go up there, I'm going to be like, okay, this is working fine, this is working fine, this is working fine, this is working fine, this is working fine. Okay, there is an error up here. So I read every statement line by line, and at the point when I found the error, I'm like, okay, we have an error up here, let's solve it. And I sort of found the error. So if I correct this, I'm going to be like, okay, I debugged the error within my code. That's the first way of finding an error within your code. The second way of finding an error within your code is by using breakpoints. So what's a breakpoint? A breakpoint is sort of like, I can say that, okay, I'm going to write one whole set of statements, and then I'm just going to see whether there is an error within the whole set. So like maybe rather than reading it one by one, I'm like, okay, just like this one function I declared, maybe I have to declare like three functions. So I'd be like, okay, let me write one whole function, and then when I'm done with the whole function, I'm going to test it at once. So like I set a specific point, right? I declared it on my own that I'm going to test it, but I'm going to wait till the whole function has been written, and then when I write everything and like the whole function has been declared in the right way, then I'm going to test whether there is any sort of problem or not. And just like that, I can also say that, okay, I'm going to test it, but after every 5 lines. So I'm going to wait for 5 lines, then I'm going to test it, then 5 lines, then I'm going to test it. The concept of breakpoint basically lies in the fact that you can basically set, or like you can stop at specific lines to check the variable's value. Stop at specific lines to check the variable's value. To check for errors कर सकते हो. Yeah, how can I figure out whether there is an error? I can basically look for the variable's value, which means that if there is some command, like I can say that I'm writing some code to basically multiply stuff, and I'm like, okay, number one is basically 2. Anything that is storing some value is known as a variable, say. And then I have number 2 as, let's say, 4. So both of them are variables because they're storing a value, right? So now if I want to multiply them, and I should be getting the answers such as like 4 2s are 8, right? But I see that I get the answer as 6. So how am I going to figure out? At this point, my computer, sir, don't our interpreters already tell us the errors line by line? Yes, you are correct. Interpreters do tell us the error line by line. But in that case, that is a scenario where you're going to make use of an interpreter separately. Okay, so if you make use of a compiler and an interpreter separately, then in that case there will be great differences between them. But at this point, you're going to note that this is an opportunity provided to you by an IDE. So sort of you can also say that, okay, let's say you all बल्कि नहीं, एक एग्जांपल आपको मजे की देता हूँ. So for instance, one of you is good with playing games, okay, but then there is one specific mission which you all cannot solve at all. Okay, so you all are very good in playing games, but then there is this one mission which you cannot solve. But then what happens is that you decide on playing that game in a gaming zone. So you go to gaming zone, and within the gaming zone you have a senior gamer who can even allow you to solve that problem, say, so he can even play that mission. So if you go till that point, even though you do not have the capability of doing that specific mission, but because you're in a gaming zone and you're working as a team, the senior gamer helps you do that too. So just like that, in this case, even if your compiler does not tell you the error line by line, because it's being compiled within an IDE, and IDE provides you with extra features. But now if I have to deal with the compiler separately, like I say that, okay, I have a file, and then I compile it separately. In that case, it's going to have the features of only compiler. But if I make it use of it within an IDE, it's also going to have some additional benefits. Now, the point where you're saying, don't the interpreters already tell us the errors line by line? Yes, you're correct, they do. But if we also add an IDE alongside it, IDE would be like, okay, you do that part, I'm going to give you other features. So now if my IDE has built-in line by line feature within it, but in this case, in this specific scenario, this thingy is giving me error immediately. And it's basically telling me the error the moment an error has been located, right? It's stopping the code the moment there is an error. So this is a feature which is being usually denoted by an interpreter. But this terminal which I have right now, this is a compiler based. Now, why is there this difference existing? It's because an IDE has this feature of debugging where basically they can go line by line too. And these tools which I just discussed, it's not like the IDE is going to make use of them. These are for the programmers. So like for instance, Hassan Abdullah, it's up to you. If you want to test it line by line, it basically works in a way. Let me share the screen back with you. उससे आपको सही समझ आएगी. So right now we have this screen in front of us, right? We have the code written. Now, when I say that I want to execute it line by line, this basically means that I can remove the other stuff, right? So I can like, okay, let me remove these two statements. Okay, let me just remove them. And now let me just test it till this point. Is it working or not? So I'm going to run it, and you see that it's running the right way. So I'm like, okay, it's working perfectly fine. Now this is what this is single stepping. I'm running it. Or perhaps this is breakpoint because I'm where I wrote like a few lines of code and then I'm testing it. But if I, let's say, start from this line number 5, this is basically single stepping. This statement is right. So now if I continue and I write the next statement, something like, okay, what's up? Oh, my bad. What's up? Yep. And then I just have this quotation mark at the end followed by a semicolon. Now, if I run this, and let's say I also have some other statement within this, and then I'm like a programmer and I'm like, okay, what I'm going to do is that I would be waiting for writing 2 to 3 lines of code, and then for every 2 to 3 lines of code I'm going to test it before moving on. So now I'm going to test it. I'm going to see, are there any errors? No, there are no. All 3 statements have been printed in the right way, which tells me that, okay, I'm good to go. Now I'm going to go on to the next statement, which I have to write, right? So this technique, which has been implemented by a programmer like me, is basically single stepping and breakpoints. Now your IDE basically provides you the chance to execute the code in this way. It's not like the IDE is automatically going to make use of single stepping or like breakpoints. It's basically providing you with these tools. Now it's up to the programmer how they want to make use out of these tools. So now this question of yours where you were saying that don't interpreters already tell us the errors line by line, is it related to this debugging point? Yeah. Okay, most probably you're talking about single stepping, right? So in this case, it's not like the IDE is reading the statement one by one. It's like letting us, the programmers, read the statement one by one. So like at this case, you just saw, I removed everything else, I compiled it, I saw that it's running perfectly fine. Then I wrote the next statement, then I again compiled it and I saw that it's working fine. Then I wrote the third statement, I ran that and I saw that there is no error, we are good to go. So this technique of basically looking for errors where I'm reading everything line by line as a programmer is known as a single stepping. It's not like something made used by an IDE. It's a tool which an IDE provides me. Now, if an IDE did not allow me to run the code line by line, if it had this let's say it had this rule that you need to write the whole code for it to run for even at the first glance, then that would be something, a rule set by an IDE, right? So but at this point you're going to note that IDE provides us with the chance to run the program line by line. So these statements, these rules, or these tools which I'm just discussing right now, these are the tools which an IDE provides to a programmer to make use of so that they can basically find errors within their code. But the second point which you also stated, even if let's say IDE, or like if I'm making use of a compiler within my IDE, there are some specific features which an IDE can provide alongside a compiler to make it even more convenient for the programmer to use. Sahi hai? Is it clear now? Okay, good. Like, still, that was a good question though. The point here to understand is that these tools which I'm discussing, it's not like the IDE is automatically applying them. It's basically the IDE is providing the programmer to make use of any of these tools, right? Just that I wrote it right now, ran one statement, checked it. If I wanted to do 2 to 3 statements at once, do 3 line code likha, ran it. So is there any error? तो फिर there is a problem. If not, I'm good to go. So these are basically debugging tools which an IDE provides me so that I can find errors within my code. Now, just like that, there is one third way of finding errors within my code, and that basically is through variable watch. Now, what variable watch does is that in your IDE, sometimes if you have multiple variables, you can basically look onto the values of the variables. You can see how the values of variables are changing as the code runs. And just like the way I was discussing up here, if you have 2 at the start and you have 4 as the second number, and you are aware that the answer should be basically multiple of the 2 and you should be getting 8, but now you see that variable, the answer variable, rather than having the answer of 8, stores the value of 6. This should be a clear indicator that something went wrong. Why? Because if everything was being conducted in the right way, the answer should have been 8. But I saw that the answer within my the value within my answer variable is 6 rather than 8, and this is a clear indicator that something went wrong. So this is one other way of basically finding errors, and this specific table which allows you to look onto the values that are within the variable throughout the program. So like maybe it's at line number 1, तब ये value थी. Maybe at line number 10 the value gets updated to something. So it basically allows you to have a look at the values within those programming statements within those variables, and this can basically allow you to figure out whether there is any sort of an error within your code or not. So we're going to write that variable watch is that feature which allows you to see values of variables, see values of variables as the code runs, as the code runs, to see if there is any error. If there is any error, that marks the end of our third feature, which basically discuss how, as a programmer, an IDE provides you a good platform or an ideal platform to locate errors and to solve them. So if your IDE did not provide us with these debugging tools, it would have been really difficult for us to find errors. And so thanks to these three features, now if I write a 1,000-line code, I can basically sort of find solutions to the problems that I have. So I can basically test specific sections using breakpoint. I can see like, okay, if I wrote a 1,000-line code, let me test the code between line number 100 and line number 270. So I can basically test the specific sections, or I can be like, okay, let me test it line by line. I can test the code line by line. And at the same time, if I don't want to test it that way, I can have a look at the variables. And this variable watch would be something which we would be even implementing in paper number 2. There would be a proper question on this, and that's not that difficult. So we're going to discuss that later on, inshallah. But this is also one method of basically looking on to finding solutions to the errors you have within your code. These are basically the three most prominent sort of features your IDE has. But this is something which is the basic requirement of a programmer. Now, afterwards, these IDEs have been upgrading over the years. And at this point, our IDEs sort of have a few extra features too, which is firstly error diagnostic. So like even if you haven't compiled the code, your programmer, this IDE can automatically figure out what error is there in your code. So we're going to say that you can have error diagnostic, and they can also help you with auto correction, error diagnostic and auto correction. So now the code which I just wrote, you're going to see that the moment I had an error inside it, there was a red statement running throughout the line, right? A red line appeared, which showed that there was some sort of an error in line number 7. And it allowed me to figure out. And now if I had to like click on that red point, it would have even tell me, and like it's going to tell me that, okay, you missed this semicolon. So this is again a feature provided to me by my IDE, that it allows me to find errors, and at the same time it also provides a solution to it, which I'm calling as an auto correction point. And both of them are something which an IDE provides. Now if I have to do coding on a basic shell or on a software which is not an IDE, a normal sort of code editor, they will not have these features. But you can see without these features, coding would be pretty difficult. So if we have to talk about error diagnostic, we're going to say that it warns the users about errors while typing, warns about errors while typing. So like even though I might not have compiled the program or have executed it, you're going to note that it's going to tell me even at the first place that, bro, there is something wrong within your code. And at the same time, it is also going to suggest me the fixes for it. So like in the case we just discussed, it's going to be like example, add a semicolon. So like I missed this semicolon, right? So it can give me this suggestion, or like it can say that okay, you had a bracket missing up, so do that. And the benefit of this error diagnostic and auto correction feature is that it helps us find logic errors and syntax errors. Helps us find logical and syntax errors. So like if there is some sort of comma being missed out, or like you would have also seen those sort of memes where people say that a person literally spent like one whole day just to figure out that a single comma or a semicolon was being missed in their code. And now that was a problem which existed back then. But nowadays, we have IDEs which can allow us to find these diagnostic the moment we miss a semicolon. So the moment there is a semicolon being missed out, it's going to highlight that specific section and it's going to tell us that, bro, you forgot adding a semicolon. And so this allows us to make our life way more easier because we are no longer going to look onto the whole code again just to figure out where did we miss a semicolon or a comma or a specific bracket. And that is something which really helps us a lot, right? So this is the fourth feature provided to us by our IDE. The fifth feature is auto completion. So like the current IDE which I was using, I have disabled auto completion. But if you install Visual Studio and you allow or perhaps turn on auto completion, if you're writing code, it's automatically going to complete the statement for you. So you might be like, okay, print, and you write hey, and it's automatically going to recommend that okay, I guess you're trying to add this, so just press the button tab on your keyboard and it's going to complete it for you. So this is a feature which might be good if you are in the professional industry to save the time, but for like you all, or like for me as students, it's not something recommended because you cannot get the chance to learn it. But this is also something which an IDE provides us, where it can suggest me keywords, variables, functions, and other names as you type. So suggests keywords, functions, variables, or other things as we type. And there are two things when we talk about auto completion. One is this case, and the other one is suggesting keywords. Now, when we talk about keywords, it is something which is really helpful. How, like, if I have to again reshare the same IDE platform to you all, you can see that while I'm up here, if I want to write some command, I can basically, like, for instance, I write the word COU, and it is automatically telling me all the functions I have. So, right, if I want to do C out and I, let's say, have something up here like with the name of x equals to 2 plus 5, this is, let's say, a variable. So I can directly do x, and it gives me all the functions or all the places which can have an x inside it. So now if I had to write this long thing, x locale string h, it is going to be pretty long, right? But if I write x, it automatically completes the statement and recommends it. Now this is one way of what we call as an auto completion, and the other one which I have disabled is, like, for instance, if I want to write hey, it is automatically going to put a semicolon up here, but which I have disabled. So in this case, it's not going to work in the right way because it has been basically disabled on my computer. But this is also one feature which an IDE provides us, and this is really important because it helps the programmers save a lot of time, and it makes their life pretty much very easy. So the second point would be that it basically speeds up coding and avoids typing mistakes. So speeds up coding and avoids typing mistakes. Because if you're writing the code on your own, or like the one which I just showed to you, writing that whole thing with this proper capital letters, there is a possibility you make a typing mistake. But in this case, if you're making use of an auto completer within your IDE, there's a great possibility, because it has been predefined, there will be no such error occurring, and this improves our whole experience of writing code. Apart from that, the sixth feature is that it has an auto documenter within it, auto documentation or auto documenter. And what an auto documenter does is that it basically generates explanations or templates for your code. So it basically automatically looks onto your code and it is like, okay, you have your code, it does this thing. So it automatically generates a sort of a document or like an explanation, automatically generates explanation or a template as to what you are trying to do, say, or a template for your code. So if you are someone who might be teaching something, some concept or something, it basically, if you write some code, this auto documenter or auto documentation software or a feature of an IDE, it is sort of give you, it is going to on its own compile a summary of what the code does. Or you can also say that if I'm taking this class right now, maybe some AI software like Gemini at this point is going to be generating notes for you all, which I can share with you all later on. So similarly, when you're trying to code something and you have to write a very big code, you would basically require a sort of an explanation or a template or a document which summarizes what you are trying to do, so that if your code is being shared with someone else, they can also understand what you were trying to do on line number 100. So now usually programmers had to type it on their own, but now this auto documenting feature of your IDE helps you with this problem, because you're no longer required to type it on your own, because the IDE automatically generates the explanation, which is a big relief for all of us. And the last feature which an IDE provides us with is the feature of pretty printing. Now, what's pretty printing? Pretty printing is this one logical thing which we just discussed at the start of the class, where your code editor has those different colors. So it basically formats the code nicely with indentation and color coding. So it gives a specific thingy a specific color, so that a programmer, if it wants, if he or she wants to look onto that code later on, they can easily figure out that this thing is basically of this nature, or this specific command is going to do this thing. So every action is given a different color, so that the programmers can later on look onto what this thing is doing. So maybe if I'm reading the code written by Hassan Abdullah, but I see that there is a code or a action which has blue color on it, so I can see that okay, blue color was something related to downloading something, so it's in blue. Maybe this has the same feature, maybe downloading or something loading, something similar to that, right? So it basically helps me understand someone else's code, and at the same time, if I've written a very long code, it allows me to have a better overview of what I'm trying to write. So pretty printing is what we call that feature where your IDE provides those specific elements a different color. So we're going to say that it formats, बल्कि यहाँ पे क्यों लिख रहा हूँ, यहाँ पे लिख देता हूँ, formats the code nicely with indentation. Now, what's indentation? Indentation is basically that specific practice of a programmer where they give those specific spaces between these code statements. So, like for instance, look up here, you're going to see that I have followed a model where I have the first statement like this, then everything beneath it is basically with one finger space. So we have some space up here, space up here, space up here. Now it's not like that this is necessary. I can sort of even write it this way, but it looks good the other way around, right? So like looking up on this thingy, it's better to have something like this, because it's going to be way more easier for me to understand that whatever this statements were, all these three statements are basically running under this heading. So if I don't write it this way, even though it will work, it would be pretty difficult for me to understand that what section is this statement being run under. And for that reason, we say that we have this pretty printing feature, which basically aligns everything onto a specific format where everything is indented. So this feature where we have these one finger gaps is basically known as indentation. This is an important point and will be discussed later on in paper number 2 too. But the main point of this pretty printing is that it basically provides color coding and color coding, which basically has the feature of highlighting everything with a different color for a programmer to understand. So ye bhi likh deta hu, so that if anybody is viewing the notes later on, they can understand. Highlights, keywords, keywords, variables, functions with different colors. So now in exam, if a table is in front of you and they say what feature is being executed at this point, and it is talking about how a color has been provided to a specific thingy, you're going to know that we are basically talking about pretty printing. Now, these are the seven features you all are required to memorize for your exams, because in exam they can tell you and they can ask you what are the features of an IDE, and then let's say they might bring up a specific feature like what does error diagnostic and auto correction do. So you should be aware of explaining what they do, what are their basic tasks, and how do they help a programmer, like generally, like helping them find logical and syntax errors. But to summarize the whole discussion, the main question which an programmer or like as students you should be asking is, why do we need IDE? Like, why use an IDE, right? So why use an IDE? So your IDE sort of has we saw that it has a lot of benefits, right? But the biggest benefit to all of us is that it saves us a lot of time. We have everything in the same software, everything at one place, everything at one place. And that is something really, really important for a programmer, because it's going to take a lot of time compiling stuff at one place, then looking up on the errors through a different report, and then maybe doing or maybe documenting it at a different place. So it's going to take a lot of time, right? So ID saves us the time. Secondly, because we have auto completion, these diagnostic tools, it helps us reduce errors. Reduce errors. Thanks to what? Auto completion and these diagnostic tools. Just like that, our ID also provides us with the chance of making debugging easier, right? Because of these softwares, I can easily locate if there is any sort of an error within my code. So I'm going to say that it makes debugging way more easier. And the last benefit of making use of an IDE is that it provides us a cleaner and more professional code. Provides us a cleaner and more professional code, because everything has been indented, everything has a different color, everything has a proper documentation alongside it. So it's sort of pretty much more easier, and it has like a cleaner interface for a programmer to work on, right? So it sort of provides us a better chance to understand the code in the right way, which eventually again works on to point number two, that it helps us reduce errors. And if something is reducing errors, this also means that it's going to save us a lot of time. So these are like the four general or the four sort of important reasons as to why a specific programmer should be having an IDE. Now, this does not mean that if you don't have an IDE, you cannot write the code. You can even write code and can build programs without using an IDE. But in that case, you would be writing code at one place, then you're going to compile it using a different software, then you're going to find errors through some other manner, and eventually at the end, you're going to write the documentation on your own too. So it's going to waste a lot of time for you. But while making use of an IDE, you can conduct all of these thingies at one specific place through one software, which is going to help the programmers save not only their time and energy, but at the same time help them find even those errors and the process of debugging way more easier. And this basically marks the end of our chapter number 4, which was software. Any questions? And did you guys understand the concept of an IDE followed by the features they have? In the chat box quickly. Perfect. बाकी भी बताओ. That's great. Perceive clear? Lisa, perfect. That's great to know. All right. So at this point, we have ended chapter number 4, but we have 8 minutes left. I have a few questions which I would like to discuss, because I thought that it would have been that this wasn't going to take that much time, but still, क्योंकि time lag gaya, so no problem. We're going to look into this one question from summer 2023, and it's basically going to summarize the whole discussion which we just had related to IDEs, and we're going to look into what this whole thing is all about. So this one question says that a programmer is writing a computer program using a high level language, and we need to basically tick one box to show which statement is correct about writing computer program in a high level language. So we basically need to talk about high level languages. So high level languages, can there do we have any sort of mnemonics? No, not this. Why? Because this mnemonics thingy is something done by assembly language, right? So straightforward, no. The second one says a computer program is harder to debug than a load. Oh man, that's relatively straightforward, no, right? Because we all are aware that a high level programming language is easier to debug than these low level languages like zeros and ones or like those assembly languages. The third point says the computer program is machine independent. That is true, right? The same point where I was talking about how if you have to write code in Python, writing code on Python through Windows is going to be the same experience where you have to write the code on some Mac OS, or maybe if you want to write the code on Linux. Throughout the operating systems, the way of writing the code is going to stay the same, which makes it machine independent. And this means that point number C is correct, which is the correct statement. And the last one says the hardware of the computer can be directly manipulated. No, that is something again which only low level programming languages allow, LLL. Now, point number B says that the programmer uses a compiler to translate the computer program. And we need to basically describe how the compiler translates the computer program. So, for that, what happens is that it creates an executable file. It translates all the code before it is executed. And the main thing is that it basically translates the low level or perhaps the high level language into a low level language or machine code. So, we're going to say that it translates the source code or the high level programming language code, the source code into machine code or into machine code, which basically means what? Into binary, zeros and ones. The second point would be how it basically translates everything before it is executed. It translates all the code before it translates all the code before it is executed before it is executed. And the third point would be the compiler creates an executable file. The compiler generates a separate executable file. Perfect, 3 on 3. Executable file. Easy peasy question, right? It's not that difficult, straightforward. The second question is now a two marker one, which means that it expects us to write 2 points. And it says that how does a compiler report errors? So we saw that a compiler creates a report, but it does that after trying to compile the whole thing. And in that, it basically displays all the errors in the code. So we're going to say that it creates an error report after trying to compile. It creates an error report after trying to compile the whole code, and in most cases you will not get a second point to write in this scenario, right? And you'll be like, okay, I wrote 1 point, I feel like I should be good to go. But that's not the case. Why? Because at this point you need to write 2 points, and now the second point would be how that specific report would be doing what. Definitely it would be displaying all the errors. So the second point, if you don't get anything in your mind, but whatever the thing we are discussing uske bare mein kuch likh do. So it will display all the errors in the code. Display all the errors in the code. Part C basically says that the programmer uses an IDE to create the computer program, and that one function of the IDE is that it has a built-in compiler or a built-in interpreter or a built-in translator. But in this case, okay, we have a built-in compiler. And now it says that we should just give 3 other features. So now we just discussed so many of the features, right? So we can write any of them. We can say, okay, we have a code editor. We can say we have pretty printing, and I can say, okay, auto completion. I can discuss the documentation part. I can say built-in interpreter. I can say error diagnostic and whatnot. So like, let's say, okay, error diagnostic. And do know, because it has a built-in compiler up here, if I write this point built-in interpreter, I will also get marks for that. That is also a perfectly valid point, because just as I said, it an IDE provides you with the chance of basically doing what? With the chance of basically reading everything line by line, which is a characteristic displayed by an interpreter. So the question where Hassan Abdullah was saying that an interpreter provides you with the same feature, you should know that it basically is the same thing. So you have like an IDE. If you have a compiler, your IDE brings in the interpreter for you because it performs the task which an interpreter do. So if you write that same point up here too, that it can work as a built-in interpreter, that is also valid. And that basically marks the end of this one question. Let me see, I had one other question too, and then we can end the class because I wanted to look onto these two easy peasy questions and फिर कर लेते हैं. Okay, this is relatively a shorter question. So let's just discuss this and then end the class. Again, this is related to programming languages, and it says that we need to explain what is meant by a low level language. So, a low level language we saw is that specific sort of programming language in which the computer's hardware is sort of directly accessed, right? And it may use mnemonics. And an example could be like machine code or like assembly language. So, I'm going to say that it is close to the language processed by the computers, close to the language processed by the computers, processed by the computers where the hardware could be directly accessed, where the hardware could be directly accessed, could be directly accessed, and then we can say that it may use mnemonics, mnemonics, mnemonics. And in these questions, you can also sort of give an example. So I can say an example could be assembly language, and we would get a perfect 2 on 2 for this, even though I wrote 3 points, but you should get 2 on 2 for this too. The second question says give 2 reasons why the programmer would choose to write the computer program in a low level language rather than high level language. So the first benefit is that when we make use of a low level language, we can directly manipulate the hardware, which is straightforward. Can directly manipulate the hardware, manipulate the hardware. Whereas the second benefit is that if you guys remember, we had a discussion on the multiple reasons as to why one should go with LLL rather than HLL. And one of that was also how it is more memory efficient, or that it is quicker to execute, and we can make use of specialized hardware. So you can write any of those points. So we can say quicker to execute, or you can also say make use of specialized hardware, specialized hardware. And this basically marks the end of this question too. So your chapter number 4 questions are not that complex, but it is sort of whatever we just discussed. It's going to ask you to basically talk about that. So like we just had a good discussion on that, on these topics, and you saw that a question directly asked you on the stuff which we just discussed in the last two classes, right? So inshallah, we are done with our topic number 4, and tomorrow, or not tomorrow, perhaps on Saturday, on the Sunday's class, we would be doing some more chapter number 4 questions, inshallah. And in those questions we are going to look into the initial parts where we were exploring how and utility software works, how your system softwares work, application softwares work, and we're going to see the example questions and examiner bring in for those topics. And so alongside this, I would be inshallah also uploading one other past paper recording from our last batch, which you all should watch, because in that we discussed the recent 2025 and 2024 questions in great depth. I'm not sure the 24 were, but I guess we did 2025 questions. So you can also have a look at that and do watch that over the weekend must. But that is all for today. We are done officially with chapter number 4. Are there any questions, or are we good to go? All right, perfect. If we don't have any question, that's it for today. See you inshallah tomorrow. Take care. Allah Hafiz.